In this video, we're continuing with Chapter 3. We're going to go through Section 5, Controlling for a Variable in a Histogram. Okay, in the 1960s, many women began using oral contraceptives, the pill. Since the pill alters the body's hormone balance, it is important to see what the side effects are. Research on this question is carried out by the Contraceptive Drug Study at the Kaiser Clinic in Walnut Creek, California. Over 20,000 women in the Walnut Creek area belong to the Kaiser Foundation health plan, paying a monthly insurance fee and getting medical services from Kaiser. One of these services is a routine checkup called the multiphasic. During the period 1969 and 1971, about 17,500 women aged 17 to 58 took the multiphasic and became subjects for the drug study. Investigators compared the multiphasic records for two different groups of women: users who took the pill, that's the treatment group, and non-users who don't take the pill, that's the control group. Okay, this is an observational study. It is the women who decided whether to take the pill or not. The investigators just watched what happens, right? So this is an observational study. What's the key feature that separates a controlled experiment from an observational study? In a controlled experiment, the experimentalists are deciding who is in the treatment group and who is in the control group. Well, for this scenario, if we look at this study here, so what they're doing is the pill alters the body's hormone balance. So because of this, they want to study what the side effects of the pill are. So a study is carried out at this Kaiser Clinic in Walnut Creek, California. Over 20,000 women in this Walnut Creek area belong to this Kaiser Foundation health plan. So they pay a monthly insurance fee to get medical services from Kaiser. One of these services is a routine checkup called the multiphasic. And so what they did was women would come in for their routine checkup, this multiphasic, and they would find out, okay, each woman that comes in, do they take the pill or not? And then when they do their routine checkup, they'll get different things checked. They'll compare the data. You know, what's the difference in blood pressure between women who have the pill, who take the pill and don't take the pill? Skin condition between women who take the pill and don't take the pill. I don't know. They'll compare all the different things that they check between women who take the pill and don't take the pill. But you can see who's in the treatment group, who takes the pill, and who's in the control group. That's all about each woman's personal choice. They have no control over that. That's why this is an observational study. One issue was the effect of the pill on blood pressure. It might seem natural to compare the blood pressures for the users and non-users. However, this could be misleading. Blood pressure tends to go up with age, and the non-users were on the whole older than the users. Well, that makes sense. The users are going to be more younger women, right? But that's an issue. That's a confounding variable, because it's known that age affects blood pressure, which has nothing to do with the pill. For example, about 70% of the non-users were over 30 compared to 50% of the users. That makes sense. The effect of age is confounded. It's confounded with the effect of the pill. To make the full effect of the pill visible, it is necessary to make a separate comparison for each age group. This controls for age. We will look only at the women aged 25 to 34. Figure 7 shows the histograms for the users and non-users in this age group. Okay? So in this section, they're talking about how you control for a variable, and they don't really give any specific technique. All they're saying is identify any confounding variables and then regroup the data based on those variables, and then make separate histograms for each of those groups. And we talked about this type of technique for controlling for confounding variables in the controlled experiment and observational study chapters. You can split the data sets into different groups to try and eliminate as many variables as you can. I mean, I can look at this and think, okay, we're just in the Walnut Creek, California area. Is that potentially a confounding variable? Maybe it is, maybe it isn't. What about just the general fact that you're not choosing who's in the treatment group and the control group? So maybe women that take the pill have different personality characteristics than women that don't. Okay, so this first histogram is, what they did was, this is just for women that were in the ages of 25 to 34. That's how they controlled for the variable. This histogram is just for women in that younger age group. So you've eliminated the variable of age. Okay, non-users is the dotted line, users is the solid line. And you can see that, so when you get to higher blood pressures, you've got higher blocks in the users group. Higher, like the area, the height, and also the area is definitely larger in these higher blood pressure regions. And then it's lower in the lower blood pressure regions, which makes sense because more non-users have lower blood pressures. So this histogram is indicating that users have higher blood pressure. You see, there's a larger percentage of users in these higher blood pressure regions. Okay, in this millimeters, that's a unit for pressure. Millimeters of mercury, that's 1 unit for pressure. Okay, so it says that the histogram that's for the younger age group, the one we just looked at, the two histograms have very similar shapes. So one was for the users, one was for the non-users. However, the user histogram is higher to the right of 120 millimeters, lower to the left. That's what we saw. High blood pressure above 120 millimeters is more prevalent among users, low blood pressure less prevalent. Now imagine that 5 millimeters were added to the blood pressure of each non-user. That would shift their histogram 5 millimeters to the right, as shown in the bottom panel of figure 7. Okay, so what they did was they took all of the non-user data, and for each person, for each non-user, they added 5 millimeters to their blood pressure. And what that did was that shifted, if we look here, that just shifted the curve or the histogram for non-users to the right by 5 millimeters. So it's interesting to note how histograms behave. That's one way they behave. If you add or subtract a constant value to the data of a histogram, it's going to shift it left or right. And they did this because what they're saying is whenever they shift it, then the user and non-user histogram look to be close to the same. I guess that's what I guess I see that. I mean, you look here, this is pretty different, but that's what they're trying to illustrate. They're saying it seems to be that non-users, like on average, had 5 millimeters less blood pressure than the users. So the pill perhaps adds 5 millimeters to your blood pressure. Okay, so it says, this conclusion must be treated with caution. The results of the contraceptive drug study suggest that if a woman goes on the pill, her blood pressure will go up by around 5 millimeters. Okay, but the proof is not complete. It cannot be because of the design. The drug study is an observational study, not a controlled experiment. Exactly. Maybe women that take the pill are more adventurous or something. I don't know. And so they tend to, they're more high octane. I don't know. Part 1 showed that observational studies can be misleading about cause and effect relationships. Yes. There could be some other factor than the pill or age as yet unidentified, which is affecting the blood pressures. You have to be careful with observational studies is what they're saying. For the drug study, this is a bit far-fetched. So what is a bit far-fetched? It's saying that there could be some other factor than the pill or age, which is affecting the blood pressures, but it's saying that this is a bit far-fetched. The physiological mechanism by which the pill affects blood pressure is well established. The drug study data show the size of the effect. So it sounds like to me what it's saying is that the pill adding that 5 millimeters blood pressure is accurate. It's known the physiological mechanism by which the pill affects blood pressure is well established. Okay, but what are they saying? There's more data. This is well established. So they've looked at other variables. There's been other studies. So they say that this is far-fetched, the conclusions, but it's only far-fetched because there's been other studies done that have proven that the pill does affect blood pressure. So the goal of this section is just to understand what variables are when you're making a histogram, when you're doing an analysis. In particular, what are confounding variables and how you control for them. So with a histogram, what they're saying is if you have a variable, then a confounding variable or variables, then what you can do is you can take your data set and group it based on those variables. So you can eliminate the variable. Like you had women, initially women of all ages or close to all ages, but age was a confounding variable. So then you just do a histogram for women of a certain, like in a certain age range. Now, the issue with this is that you have to make sure that whenever you do these groupings, you can't all of a sudden create groups that have too small of data points, right? These are statistical studies. You're looking for just patterns, averages. You need a sufficient number of data points, right? If you took this, what was it? 17,500 women here that did the study, and you broke it up into 50 different groups. Well, at some point, you know, if you're only making a histogram with 100 data points, maybe that's not, you know, you need data points. You're looking for like these, it's statistical. Now you might be wondering, what is a sufficient number of data points? We're going to talk about those kinds of ideas later in the book. Okay, let's answer some of these questions. As a sideline, the drug study compared blood pressures for women having different numbers of children. Below are sketches of the histograms for women with 2 or 4 children. Which group has the higher blood pressure? Does having children cause the blood pressures of the mothers to change, or could the change be due to some other factor whose effects are confounded with the effect of having children? Okay, so we can see that the dotted line histogram is more to the right, which means that the blood pressure on average is higher for women with 4 children compared to 2. Okay, so there is an association here. There is an association between women with more children and higher blood pressure, but causality, I mean, it's hard to say. I mean, you could potentially argue that age is a confounding variable here, because women with a higher age tend to have more children. And we know that age is a causal association with blood pressure. The higher the age, the higher the blood pressure on average. And then I'm looking in the textbook here, the solutions say that after controlling for age, so what does that mean? That they redid these histograms, but just for like a lower age group or a higher age group. And then this association disappeared. Okay, hypothetical. The sketches on the next page show results from 2 other studies of the pill for women aged 25 to 29. In one study, the pill adds about 10 millimeters to blood pressures. In the other, the pill adds about 10%. Which is which and why? Okay, well, we talked about how if you just add or subtract a constant value to all of the data sets of a histogram, then it strictly shifts that histogram left or right. And so this isn't a shift here. This is different than a shift. This is a shift. So this must be adding, and it shifts to the right as well, which means that it added 10 millimeters. It was a constant was added. And that's what it says. In one study, the pill adds about 10 millimeters to blood pressure. So the dotted line is the user. So the dotted line, they have the pill. They took the pill. Okay? And so this would be, you can see this gets a bit wider. If we're comparing percentages, we're comparing the areas. So all of a sudden you have users and it gets a bit wider.